For as long as humans have looked up at the night sky, we have asked the same question.
Are we alone?
It is perhaps the most profound question our species has ever dared to ask. And after thousands of years of searching, we still do not have a definitive answer. But what we do have is evidence, patterns, anomalies, and a universe so vast, so incomprehensibly large, that the idea of solitude begins to feel less like humility and more like arrogance. The observable universe contains an estimated 2 trillion galaxies. Our own galaxy, the Milky Way, holds somewhere between 100 and 400 billion stars. In 2022, NASA's James Webb Space Telescope confirmed what astronomers had long suspected, that nearly every star hosts at least one planet. That gives us a number of planets in the observable universe that stretches into the quintillions. Against that backdrop, the claim that life exists only here, on this one pale blue dot orbiting an unremarkable star on the edge of an average galaxy, requires an extraordinary burden of proof. In 1961, astronomer Frank Drake developed a mathematical framework now known as the Drake equation. It attempted to estimate the number of communicating civilizations that might exist in our galaxy alone. Depending on the variables used, the equation yields results ranging from just a handful to millions of active civilizations. Yet despite those numbers, we have received no confirmed signal, no verified contact, no unambiguous proof. This silence is what physicist Enrico Fermi captured in a single devastating question back in 1950. If intelligent life is so probable, where is everybody? That question became known as the Fermi Paradox, and it remains one of the most unsettling open problems in all of science. But science has quietly been dismantling the assumption that life requires
Rare and delicate conditions.
Here on Earth, we have discovered organisms called extremophiles, life forms that thrive in boiling hydrothermal vents on the ocean floor, in highly acidic rivers, in the frozen deserts of Antarctica, and even inside nuclear reactors. These discoveries have fundamentally expanded our definition of what a habitable environment looks like. Meanwhile, astronomers have detected complex organic molecules, the chemical building blocks of life, drifting through interstellar space. Amino acids have been found inside meteorites. In 2020, scientists announced the possible detection of phosphine gas in the atmosphere of Venus, a potential biosignature that sparked immediate global debate. Within our own solar system, the search has grown increasingly urgent. Mars once had liquid water on its surface, rivers, lakes, and possibly oceans. NASA's Perseverance rover, which landed in the Jezero crater in February 2021, is currently collecting rock samples that may one day answer whether microbial life existed there billions of years ago. Europa, one of Jupiter's moons, hides a vast saltwater ocean beneath its icy crust, kept liquid by tidal forces generated by Jupiter's enormous gravity. Enceladus, a moon of Saturn, actively shoots water vapor and organic compounds into space through geysers at its south pole. Astrobiologists consider both moons among the most promising candidates for extraterrestrial life in the entire solar system. The conversation took a sharp and unexpected turn in 2017, when the New York Times published a landmark investigation revealing that the United States Department of Defense had been operating a secret program to study unidentified aerial phenomena, UAPs. The program, known as ATIP, had been quietly funded for years. What followed was a wave of declassified footage, the Nimitz incident of 2004, in which U.S. Navy pilots encountered a craft that defied known aerodynamic principles, moving at hypersonic speed with no visible propulsion system and no heat signature. In 2021, the US government released an official intelligence report acknowledging 104 UAP encounters that could not be explained. In 2023, former intelligence officer David Grush testified under oath before the US Congress, claiming that the government possesses non-human craft and biological material of unknown origin. These claims remain officially unverified, but they were made under oath in front of the United States Legislature. On August 15, 1977, a radio telescope at Ohio State University detected a signal so extraordinary that astronomer Jerry Amon circled it on the printout and wrote a single word in the margin: "Wow!" The signal lasted 72 seconds, matched the predicted profile of an interstellar transmission almost perfectly, and has never been detected again. Decades of follow-up observation have produced nothing.
To this day, the WOW
signal remains the strongest candidate for a transmission of extraterrestrial origin ever recorded, and it remains completely unexplained if we were to confirm the existence of even microbial life elsewhere in the universe. It would represent the most significant scientific discovery in the history of our species. It would not merely answer a question, it would rewrite our understanding of biology, philosophy, and our place in the cosmos. And if that life were intelligent, the implications would be beyond calculation. Every religion, every government, every institution built on the assumption of human uniqueness would be forced to reckon with a new reality. We do not yet know the answer. The universe has not confirmed what it holds in its depths, but the evidence, the sheer mathematical probability, the extremophiles, the organic molecules in space, the unexplained signals, the declassified footage, the sworn congressional testimony, suggests that the question itself deserves more than dismissal. Perhaps the most honest answer science can offer today is not yes and not no, but something far more powerful: we are still looking. And in a universe of 2 trillion galaxies, that search has barely begun.